Hello, everyone. Welcome to the session 3 of the data science for trading professionals and risk managers. In this session, kind of building up on the examples that we developed in the previous sessions, which was the introductory session on data ingesting and data cleaning or data wrangling in the second session. In the third session, we're gonna look at visualization, and we're gonna explore some of the packages in R that would allow us to do that, and that's basically looking at it from a exploratory type of visualization as well as visualization that's fit for presentations. There are lots of packages in R similar to a lot of other analytic tools, and visualization being one of the most important discovery tools for any data scientist when they want to basically explore and see trends in the data, as well as presenting your results and making an impact and basically allowing a decision-making process on that data to take place. So there are both aspects to visualization, and there are different types of visualization that are fit for either the exploratory visualization, as well as there's some packages that are basically more suited for explanatory sort of visualizations or analysis, which is kind of at the presentation stage. The two main packages that I'm gonna introduce you to is a package called ggplot. ggplot is a package that effectively produces static graphics. So it's very much similar to what you get in something like for example, Excel, which you basically produce the graph, and the graph can be saved as a static PNG file or JPEG file. There are also a class of visualizations that are JavaScript based and can be used and deployed in R, and has huge potential and huge applications when you start developing web products using R and R Shiny, which we're gonna talk about in more detail in the last session, which is creating data products online. So the packages we're gonna look at in this session are ggplot2, dygraphs, which is part of the family of JavaScript sort of packages, and also I'm going to introduce a package to you which is called Plotly. One of the functions, it's a JavaScript-based package which gives you a very rich visualization tool, very much similar to commercial packages such as Tableau and so on. But also I want to demonstrate a functionality within Plotly which allows you to convert a lot of static ggplot type graphics into a interactive JavaScript-based graphic, which helps you a lot. So you can develop it in an easier sort of format in ggplot, and then go ahead after you're happy with the graphics that you created. You can actually make it more interactive and deploy it online. Graphics in general, I find it to be usually quite useful at the beginning of any sort of analysis, and then at the end when you deliver the results. I usually, personally, I tend to use ggplot for exploratory type of analysis, which I want to basically look at the trend in the data based off of certain classifications, or if I want to do some sort of inference analysis and find a relationship between two data series. So to get started, I basically I'm going to load the session file from the previous sessions. So session 1, as you recall, this was the static, or this was the data frame of the Bitcoin example that we downloaded. And from session 2, which was a data series that was converted into a XDS format. I'm going to make use of both formats, and to demonstrate that you might need to do a lot of conversion depending on the packages that you want to use. So I assume that you have installed ggplot2 in your R IDE. So I go ahead and load ggplot2, and I load the dplyr package for any sort of cleanup of the data that we might need to do as a process. So a simple example for us to get warmed up, it's basically I take the prices data frame. What I'm interested in is effectively do a simple simple trending of that data. I just want to identify the trend in the data. So I can basically very easily pipe my data into a ggplot function. I define my x and y axis. Obviously, in this case, I need to convert the x-axis into a date format. You can do that beforehand. You don't necessarily have to do it within the ggplot function. And then my y-axis are the Bitcoin to USD prices. So if I run that by itself, what I'm going to get is, I'll show you in a second that if I run that by itself, I'm going to get an empty plot. And this is how ggplot works. So you basically set up the basics of your plot, and then you can start layering in different objects on top of it. So in this case, I basically set up the parameters of the graphic that I want to present, and then using this plus function, I can basically layer in different objects on top of it. This is very similar to the base graphic package in R, but ggplot obviously gives you way more functionality than your base plot. So I basically, to kind of go ahead and run the example, this is what I'm going to get. So this is effectively looking at the prices of Bitcoin in USD denominated Bitcoin, starting from beginning of 2014 and going to now. So this is not a very attractive plot. So there's there's a lot that can be done to make this look nicer. So and then I'm going to basically show you what are the things that you could do, and and you can go ahead and experiment with it and add more layers effectively to your plot. So in this case, one of the things I want to do is I want to basically factorize this plot. I want to look at classify the data that are, depending on the year, I want it to have them shown in different colors. I want to label my plot a little bit nicer, and then change the angle of the date field here, and also basically add a trend line, because not necessarily in this price series, but there are lots of type of data, time series data that you look at, and you really want a way to understand what the trend is. So you usually run a linear fit through the data. It doesn't necessarily have to be linear, but any sort of fit, and you want to basically understand the trend and be able to visualize it. So to run the example as a whole, I'm going to select the now. So this is basically linear fit through different factors. So it's basically I want to look at, in 2014 what was the linear trend, and identify it and color code it differently. And in 2015 and in 2016. So it kind of helps you to, in a lot of pricing data, to kind of identify and label the regime changes in the pricing environment, for example. So that's kind of a basic example of this. There are lots of different types of geometries that you can layer in onto your ggplot function. Some of the basic layout functionality needs to change in the process, but it's not a whole lot. So you can kind of effectively have some of the basic stuff constant, and then just basically replace different sort of geometry that you want to layer into your plot. So in this case, I want to do a box plot. Box plots are actually quite useful in understanding things such as outliers, factor by certain factor, in this case year, for example. So if I run this, I'm going to get a box plot for each year, and all the outlier points in my data series are shown in color red, which basically in this case, this is the functionality that you can add under the geom_box. So one of the main things I use ggplot for is to understand the relationship between different data sets. In this case, I want to basically get a sense of what is the relationship between price CAD and price USD of the Bitcoin prices. I want to do a point plot, and I want that relationship to be factored by different years and have some sort of linear trend to help me understand how the data is related. So yeah, so in this case, as you see, I basically my x-axis is CAD prices, USD prices in the y-axis, and then I basically see the relationship between the two and how it changes over the year. I mean, meaning that how the data is correlated in 2014 versus 2015 and 16. Although I'm looking at the actual prices, usually this is done using price returns. But this is just generally for the demonstration purposes. There are lots of great examples that you can take from the web. I tend to, generally when I want to look at a ggplot, there's a lot to be learned in terms of the syntax. What I usually do is I effectively Google the type of chart I want under ggplot. So I basically say line chart ggplot2. You're gonna get many hits on it. However, what I do is I basically click on images, and a whole bunch of images show up here. So these are all the images that were created using ggplot. So if I choose one of them, you can click on, for example, this one, and what you can do then is effectively, rather than looking at the image, you can go and visit the page that you're interested in, which is usually a page that takes you to Stack Overflow, in which case you can basically look at and copy and paste the code that generated that image. This is very common in terms of how to find the plots that you're interested in. One of the things I have to give you a heads up on Stack Overflow: always scroll down to the bottom, because it's usually people asking questions, so you actually want to get to the right answer, which is usually the last answer that was given on that specific question. So, in the past I would basically look at the example itself and it wouldn't work, and it was frustrating. So just a quick tip, that always scroll down to the bottom to get the right answer. So for example, I mean, in this case, a while back I was looking at, not only to show the relationship between the two data series, but also get a sense of the distribution of the prices for either y or x-axis. So this is an example. It's a little bit extensive, so I'm not going to go through it in detail. But you know, it's kind of to give you a sense that you can actually layer in whole bunch of plots and mix and match. So so you can actually get more complicated and nicer plots. So I'm going to run this. Obviously, it's going to take a little bit longer to produce it. Then you can basically you see that you know, not only you get the relationship separated or factored by different years, but also you get a distribution of the prices for each year. So it kind of gives you a little bit more understanding around your data and how it looks like and what are the relationships between them. So that's basically, that covers effectively what I had to say about ggplot. So here I just want to change gears and look at some of the JavaScript-based packages. There's a fantastic page or fantastic site called HTML widgets, and under that you can basically, if you click on the showcase, it gives you a whole bunch of different projects or different open source projects that would allow you to render JavaScript graphics through R. So these are all packages that you can install in your environment, and it gives you quite an interactive environment, which you can then, you know, make your you know, create data products, deploy it online as a HTML site, as well as, you know, using Shiny, making interactive graphics using R. So there's lots to be done, and you can basically expand on this quite a bit. And it's quite an active sort of project. So, you know, there's lots of projects that are in works, and, you know, people tend to use a lot of D3 packages, which is one of the open source graphic environments that people make really nice interactive graphics, and a lot of people have taken those graphics and basically wrapped them into R functions. So there's lots to be done. So as an example, for example, I'm looking at I want to basically plot the time series data for PriceCAD and PriceUSD, but I want to give it a little bit more interactive features. So basically, I can scroll over the data and be able to see what the numbers are, as well as being able to select a part of that data, very much similar to what you find in, for example, Google Finance. So there's another example that, you know, you can basically look at, for example, a volatility band around your prices, and effectively have a max and min volatility, and you know, be able to kind of create a plot which would tell you that whether if the price move was within within your confidence band or not. So it kind of gives you a little bit more analytic tools that you can deploy and layer in on your graphics. The feature that's quite obviously interesting is the ability to make this interactive and make it and deploy it very easily online. So as I mentioned before, one of the problems with ggplot is that it's not very interactive. However, there's a package called Plotly, which would allow you to make your ggplot quite interactive. For example, in the example that we used to, we looked at CAD versus USD prices in in a point plot, we can make it interactive. So it would allow us to click on a point on the chart and be able to understand what numbers we're dealing with. So, for example, if I run that, you would see very similar sort of graphics as what was shown before in the previous example. However, now you have this feature that would allow you to hover your mouse over each data point, and then it would give you beside it, it would give you the number. For example, it's 900 in 2016. So USD denominated Bitcoin was 900, the CAD one was 917, and year was 2016. So it gives you more interactive features, so you get the best of both worlds. There's lots to be said about graphics, and there are lots of packages. It's very active development within the R world. So I'm providing you with further learning and links. Hadley Wickham is the developer of ggplot2, and he has a book which is freely available online under ggplot2.org. Obviously, I showed you the HTML widget site that you can basically browse through different examples and get inspired and start using some of those packages. And also, if you get more advanced in graphics, obviously D3.js is an active open source project that is focused primarily on JavaScript-based graphics, and it gives you a whole bunch of libraries. So in many ways, you can effectively take any of those JavaScript libraries and wrap them into R functions and customize it to your liking. This ends the data visualization and session 3 of the series. I hope you enjoyed this, and you're going to join me for the next session, which is focused around model building.